Hello friends, this is Jim with Science Talk. In this video I want to discuss with you kind of a continuation of the my video series talking about ocean currents. Recently the hurricane season has officially started for the Atlantic region, and what I wanted to do is put this in relation to what I discussed in my last video about the AMOC slowing down. Now, you may recall that in that video I mentioned that the conveyor belt is a heat transference mechanism for the planet. Warm water is brought from the tropics to the polar region. Cool water from the polar region is brought back down to the tropics, and it's kind of a big convection cell, if you will. But now with the slowdown of the deep water formation, what's called the meridional overturn circulation, with that slowing down, the return flow, the North Atlantic deep water, the return flow starts slowing down. Now, I already discussed the implications of that, and that this could, according to modeling done by Wally Brokert, could bring on ice ages and so forth, as well as collapsing the Southern Ocean productivity region, because the Antarctic divergence zone, the upwelling that brings the nutrients that allows that ecosystem to flourish, will not be happening. But now let's take that in context and talk about hurricanes. If we don't have the return flow of the cool water from the poles to the tropics, if we leave all that warm water in the tropics and mid-latitudes, what do you suppose is going to happen to hurricanes? What feeds hurricanes? Warm, moist energy. So now we're going to have a huge reservoir of energy to tap into. Having more warm water in the tropics and the mid-latitude region is going to fuel the storms. There's going to be more warm water that will keep these storms, make them stronger, make them last longer, and perhaps as they start tracking up the eastern seaboard, bring more of the torrential rains, winds, and so forth to more regions. Now, is this what happened with Sandy? No definitive studies have been done to test that hypothesis, to see if Sandy was the result of the slowdown in the Atlantic meridional overturn circulation, was the result of specifically the Gulf Stream slowing down, leaving the warm water in the lower latitudes. No one has tested that hypothesis specifically. They did say that this is most likely the result of global warming. But what I've been talking about is one aspect of what happens with global warming. When we melt the Greenland glaciers and you add all that fresh water, it does what? It reduces the density at the surface. So when that warm air is given off, when the Gulf Stream gives off its heat, instead of being cold, very salty water, it's cold water but not as salty, so it's not as dense, so it's not going to sink as much, if at all. And of course, if that sinking does not take place, the northern flow slows down and the water kind of backs up. The whole Gulf Stream will slow down in its movement up the eastern seaboard. If it slows down, you leave that warm water reservoir that the hurricanes can feed off of. Do not recall, we had 3 major hurricanes in a row last year. You know, we saw what Harvey did to Houston. You know, dropped a load of water, lots of water. And then, of course, you know, the devastation to Puerto Rico, which they still have not recovered from. And so what we're going to most likely be seeing is an increase in the number of storms, an increase in the intensity of the storms, an increase in the amount of precipitation, an increase of the most likely wind speeds. They're probably going to have to create a category 6 now, because I forget which storm it was last year, had sustained winds over 180 miles per hour. So that's one of the consequences of this. Basically what's happened is the system has been perturbed. It's been perturbed by the activities of humans, adding all this extra carbon in the form of CO2, methane, and so forth. And the system, in attempting to find its new equilibrium, because the perturbations continue, this system cannot find the new equilibrium situation. And so it's still going to be chaotic activities. So while the slowdown of the overturn circulation, the slowdown of the formation of the deep water is taking place, it will be, let's put it this way, it will not be instantaneous that, oh, tomorrow we have an ice age. There's a lag effect. Don't forget, there's the specific heat of water that needs to be taken into consideration. And there's the inertia of the system itself. I mentioned last time that there may be enough CO2 in the atmosphere to, at least for a little while, forestall any advent of cooling temperatures, perhaps eventually leading to advanced ice sheath growing and advancing. This remains to be seen. We can certainly look at the past records to and understand what happened there, and use that information, that knowledge, to make predictions, make certain prognoses about what's going to happen. But the thing is, the climate is changing. And where it's going to take us to, where it's going to lead us to, we don't know. It will not be good, though, however. If we have sea level rises, there will be many people across the planet that are displaced. If we have increased devastation of storms, there's going to be, again, more hardship that such storms will impose as they do what they do. So I wanted to tie that in with the hurricanes, the possible strengthening of hurricanes, the increased intensity of hurricanes, the increased number of hurricanes, with the fact that the Gulf Stream is slowing, so it's leaving warm water pooling behind in mid-latitudes. And because the overturn circulation is slowing down, the deep water formation is slowing down, we're not having the return of cool water. Cool water kind of tamps down the strength of hurricanes. So, as with everything else, this is part of a big feedback system. Part of a, for example, there are negative feedback loops and there are positive feedback loops. Now, positive and negative do not mean they're good or bad. Positive feedback loops are such that they exacerbate the situation, tends to lead to a runaway situation. For example, you warm the Arctic, you increase the thawing of the permafrost. The permafrost releases methane gas. Methane is a greenhouse gas, a very powerful one. Methane will now trap more of the long wave radiation, it will trap more of the heat. Air temperatures increase further, the thawing increases further, more methane is released, and so forth. That's an example of a positive feedback loop, system getting away on you. Negative feedback loop are corrective in nature. If something overshoots a little, corrective measures take place to bring it back down. If it goes under a little bit too much, corrective measures are put in place to bring it back up. So basically what happens is you get an oscillation around an average value of some sort, whatever that may be. So negative feedback loops are corrective, positive feedback loops lead to runaway systems. We are creating positive feedback loop situations across the planet. So that will not be good. That is leading to increasing chaos, and it will lead to increase in the severity of the changes in the climate, the severity of storms, and so forth. For example, you can be in the northeast of the U.S. and you could have 26 degrees Fahrenheit one day and 10 inches of snow, and the next day be 57 degrees Fahrenheit and it all melts. They just have these wild swings and so forth. Those wild swings are examples of the system in chaos, of the equilibrium stasis being perturbed. So it will be interesting to see what happens with this hurricane season, to see how many storms form, what the severity of the storms are, what they do. If these storms do turn out to be like a repeat of last year, high winds, high precipitation amounts being dropped, think back to what I described to you about the Atlantic meridional overturn circulation slowing down, the Gulf Stream slowing down, and so forth. It's all related. Thank you for watching. Please subscribe. Please hit the bell. Please share my videos with those you know on social media. I hope you will consider supporting the work I do. Go to patreon.com/Science Talk with Jim Massa. If you are a patron, I thank you for your support and continued support. Thank you.